For question 3, we have a certain set of cash flow again. So we have cash flow at time 0, time 1, time 2, and time 3. And then we have several things to show. So first of all, we need to show that this I over here is a root to the yield equation. So remind ourselves that the yield equation, it's such that the sum of all present value of all cash flow is equal to 0. And then for all the cash flow that we have 0.72 at time 0, so 0.72, and then negative 0.98 at time 1, and then negative 0.7, so negative 0.98 at time 1, negative 7 at time 2, and then a final cash flow of 1 at time 3. And then we need to show that this expression here is a solution. So since I've written this out in terms of v, so let's just express this in terms of v. So if I add 1 to both sides, we get negative 8 to the negative 1. So v is just 1 over 1 plus I, which is just negative 8. So if you substitute negative 8 into this expression over here, you will see that it is indeed equal to 0. So all you have to do is just substitute it into this expression, and then if you find that it's equal to 0, which it should be, then essentially you've proven part A. So for part B, we need to find the other solutions to the yield equation. So all the roots where I is larger than negative 1. So in order to find the other roots, we're going to have to factorize this polynomial. So let us just copy out what we have. So minus 0.7 v squared minus 0.98 v, and then plus 0.72. So we know that v minus 0. So we know that v equal to 0.8 is a solution. So you can expect that for this polynomial here, we can actually factorize this as v minus 0.8 multiplied by another polynomial. So in order to find this other polynomial, we're going to have to do long division. So this is just high school math. So first, consider v squared, so minus 0.8 v squared. So this minus becomes a plus, so it becomes negative 0.1 v squared minus 0.98 v plus 0.72. And then for the second term, we'll put 0.1 v, and that would give us 0.1 v squared minus 0.08 v, just give us negative 0.9 v plus negative 0.72, and then the last term will be negative 0.9. So negative 0.9 v, and 0.9 multiplied by 0.8, that's exactly equal to 0.72. So you find that this is divisible, which it should be, because we know that 0.8 is a solution. So this polynomial here becomes v squared plus 0.1 v minus 0.9. And then to find the other solutions of the yield equation, we're going to have to factorize this expression here. And then to factorize that, all you have to do is just to substitute it into your quadratic equation program, which I suppose you have in your calculator. And then you will find, or you can use the cross method if you are familiar with that. So in the end, you get v minus v plus 1, v minus 0.9. And then that is equal to 0. So you see that there are three solutions. V is equal to 0.8, which we know this is one of the solutions that was given in part A. V equal to 0.9, and then v equal to negative 1. And then this solution we can disregard because this corresponds to the case where I is equal to negative 2. And then we're just looking for solutions where I is larger than negative 1. And for the other case, so with this we've already considered in part A, it was given to us. So we found one extra solution, v equal to 0.9. And that corresponds to I being equal to negative 0.9 to the power of negative 1 minus 1. So this is the other solution that we found. And then from part A and B, we can find that there is one drawback of using the yield rate in determining whether a project is acceptable or not. And it's obvious that there is a big problem, is that we found two yield rates. And suppose we have two separate cash flows we want to compare, and we want to know which cash flow is better. We can't really exactly use the yield rate to compare here because there are two yield rates that we can use. So it doesn't really make sense even to talk about having a yield rate here because there are multiple yield rates. So this is one drawback of using the yield rate as kind of like a benchmark to determine whether an investment is good or not.